Well, for our final lesson, we're going to talk about conservation of momentum for rigid bodies. And then first off, just like with particles, that if there are no external linear impulses, then the linear momentum is conserved. That is basically the sum of all of the mv's initially equals all of the mv's afterwards. Now, again, this is oftentimes used with collisions where there is an impulse, but if I take the two bodies together, that impulse is internal, therefore there are no external impulses, and momentum for the entire system is conserved. Again, talked about that. That holds true with rigid bodies as well as particles. The difference here is with the rigid body, we can have some rotation. Okay, so but the exact same concept is true. If there are no external angular impulses, no external moments, then angular momentum is conserved. And the same idea, you can take two things together, oftentimes with collisions, to get rid of those. But again, initially, my angular momentum equals the final angular momentum if, for the system, there are no angular impulses on the system, no external moments. Okay. Now, again, these problems are often done with collisions. We have impact problems. We're going to talk about eccentric impact. And really, this is just the impact of rigid bodies where the line of impact does not necessarily connect the mass centers like it did with the particles. Okay, so it's just some arbitrary line of impact between two bodies. Does not connect the mass centers. It's the exact same idea. Conservation for the system is still conserved. This time we're looking at angular momentum, and that's about, say, this pinned point here, that fixed rotation, or the center of mass. Was the two places, again, that we can sum moments about. So angular momentum for the two bodies is then conserved because the only impulses, say, in this system is the impulse between the two bodies and the impulse at point O. Well, if I take the bodies together, that gets rid of the internal impulse, or makes that impulse internal. And if I take the angular momentum about point O, that external impulse goes to zero for an angular impulse. So again, same idea. It's just applying the conservation of angular momentum for the two bodies here. Okay. Now the other thing we've got is the coefficient of restitution, and again, exact same equation, exact same concept. Only difference is we need to look at the velocity at the point of impact, along that line of impact, which is not necessarily going to connect the mass centers again. But it's the same equation we used before, just you have to apply it at the point of impact along the line of impact. Okay. So again, if there's no external impulses, momentum is conserved. Okay. Keep in mind that you can conserve linear momentum and not conserve angular momentum, or vice versa. In fact, you can conserve linear momentum in one direction and not another direction. Okay, so you may have one or two or all three could be conserved, or not. Okay, they're not related in that you can have one conserved while the other one is not conserved in a certain direction, both linear or angular.